All right, so let's take a look at this. So basically the idea is that has this lemonade cart business and wants to do a couple calculations to make some decisions primarily about what price point to set, as they say. And the mathematics that we sort of get in this opening couple of paragraphs is that he sells 1,000 cups per week when he charges nothing. In other words, that's how many he can give away. For every extra dollar he charges per cup, he'll sell 200 fewer cups. Okay, so that's the basic mathematics that we have so far just from the opening pages. So then we're told, okay, here we have this table and we want to fill it out assuming that the pattern continues to hold. So what we see here is that every time the price goes up by 1, the number of lemonade glasses that we sell goes down by 200. And so when we go from 2 to 3, we're going to go from 600 to 400, and then we're going to go from 400 to 200, and by the time we charge $5, no one wants to buy it. It's too expensive. Okay, so the equation that we came up with, since the rate of change is negative 200, in other words, every time price goes up by 1, glasses demanded goes down by 200. So that's a negative 200 rate of change. The equation we came up with is that the number of cups sold is equal to negative 200 times the price plus 1,000. Or we could call it y is equal to negative 200x plus 1,000, where y is the number of cups and x is the number of dollars. So then we say, all right, well, does this predict successfully how many cups will sell, or I will sell if I charge $2? And we can look at the table and say $2, $600 cups. So we plug it in, we say, is it true that 600 is equal to negative 200? Let me make that a little clearer. Negative 200, which is our slope, times our value of x, which is 2. So equals negative 200 times our value of x, which is 2, plus 1,000. Well, this is equal to negative 400 plus 1,000 is equal to 600. So it checks that that equation does work for this value in the table. And so we just wanted to do a check of that. But then we said, all right, well, what if I sold 500 one week and I want to know what price did I charge because I can't remember. Well, now we need to plug in, but we're not plugging in for x, we're plugging in for y, because we said, again, y equals negative 200x plus 1,000. And again, x represents the price, y represents the number of cups. So we're saying, well, what if y is equal to 550? What then must our value of x be? So we set up our equation. We want to figure out what x is. So we're first going to subtract 1,000 from both sides to get negative 450 is equal to negative 200x, because we subtracted 1,000 from here, so all that's left is the negative 200x. We divide both sides by negative 200, and over here, a negative by a negative, this is going to end up being 225. This is going to be x. So in other words, when we set a price of $2.25 per cup, we'll sell 550. Okay, so now we're going to figure out the revenues, because we know how many cups we're selling at any given price. But to figure out the revenues, which is how much we earn from doing that, we need to say, well, let's see, when I charge 0 per cup and I sell 1,000, well, that's still going to be $0 that I earn. If I set a price of 1 and sell 800, that's going to be $800 that I earn. If I set a price of 2 and sell 600, well, now it's 2 times 600, or 1,200. 3 times 400, again 1,200. 4 times 200, now it's 800, back to 0. So you notice the pattern. This is very common with quadratic. We have this pattern that goes up and then it comes down again, and it's symmetrical, just like our parabola is symmetrical. Left and right sides are the same. So in this case, this would be something like, all right, for 800, we would have two different prices that we could set to make $800. We could set $1 for our price, or we could set 4. Okay, so that's our quadratic pattern there, going up and then coming back down again. Somewhere in the middle, we'll get our maximum number of cups. So let's go on to the next, and it's saying, what is my prediction about the revenues that will, this should be about the price that I will set that will generate the highest revenues. Well, if we go back to our table, we can see that when x was equal to 200, we had revenues of 1,200. When x was 300, we had revenues of 1,200. And from here it goes down, from here it goes down. So somewhere in between these two would be my maximum. And I'm pretty sure that it's going to be exactly halfway, which means that at $2.50, I would generate my highest possible revenue. So now, if X is how much we are charging per cup, and negative 200X plus 1,000 is how many cups we'll sell. Well, in order to know how much money we earn, we have to multiply how many cups we sell by how much we're selling each cup for. Well, and here we have the price of X, and here we have the quantity, and the revenues then has to equal the price times the quantity. So in other words, X times negative 200X plus 1,000 has to be the expression for our revenues. If I multiply that out, I end up with negative 200X squared plus 1,000X. I multiplied the X times negative 200, the X times 1,000. And so then this, or just written like this, X times negative 200X plus 1,000. Either one of these is the equation for my revenues. And we can see with the x squared here that we have a quadratic, which is why we end up with the parabola. Okay, so now we want to go into Desmos, and we want to start to take a look at how some of this looks inside Desmos. So first of all, little mistake here. This should be negative 200x, as we've been using all along. Okay, so we go into the Desmos graphing calculator, and we're going to type in here that P of X is equal to X, and that's just our, sorry about this typing here, that's just our price, and that's just, we said we're going to call that X. Okay. The quantity, which is how many cups we're going to sell, is equal to negative 200 times X plus 1,000. Oops. And what we said was that we're going to create yet another function that is equal to the product of these two. So R of X is equal to P of X times Q of X. And when we do that, you'll see we're going to get a quadratic, but it's hard to tell that right now because what we're going to do is we actually want to change this because we want our y values to go all the way up to about, let's say 1,500, and our y values will go down to, let's say, negative 200, and our x values will go, let's say, from negative 5 up to Really all we have to do is go out, let's go up to 8. Okay, and so now what we see is we have our quadratic, and when we click on it, then we can see that we're going to get a couple points here. The first point is this vertex at 2.5, 1250. That is that if we set a price of 2.5, we're going to get revenues of 1,250. That's our maximum. If we set our price equal to 0, we're going to get $0. If we set our price equal to 5, we're going to get $0 because we won't sell any. At 0, we'll sell 1,000, but we'll only get $0 per cup. So 1,000 times 0 is 0. So now notice that we've added y is equal to 800 here, and what we can see is that it's going to intersect our parabola in two different places, and if we click on it, we can see and check this point, we get the point 1,800, and we also get the point 4,800. What that means is that if we charge a price of $1, our revenues will be 800. If we charge a price of $4, our revenues will also be 800. And so as we move this, we could say, well, for any particular value here, I could determine what would be the two prices that I could set to generate that amount of revenue. So let's say we set this at 500. Well, now when we tap here, we get a price of, for $500 in revenues, we'd have to set a price of 56.4 cents, or we'd have to set a price of $4 and basically 44 cents. In each case, we get $500 in revenues. In the first case, we would sell a lot, but we would make very little per cup. In the second case, we would make a lot per cup, but we wouldn't sell that many. And so you can see for each price along here, there's two different X values that go with that particular level of revenues. Okay. Meanwhile, we saw that our vertex was at 2.5, 1250, which meant that at a price of $2.50 per cup, we would generate revenues of $1,250. Our x-intercepts were at 0, 0, and at 0, 5, because at $0 price, we would sell 1,000 cups, but we wouldn't make any money off of them. At $5, we would make a lot of money off each cup that we sell, but we wouldn't sell any, so we would make 0. The y-intercept is 0, 0. Okay, each of these points has a particular meaning in this case. So we said the vertex represents the price that we would set to get the maximum amount of revenues. That would be the x value. The y value would be what those revenues are. The x-intercepts show us the 2 points where we would make a profit of exactly 0. And then we've done this now. We got the coordinates of these 2 points. And again, what these 2 points mean is that at $1 and $4, our revenues would be exactly $800. Okay. Moving right along, we get to our costs. So we have our fixed costs here, which are the costs that we have to pay no matter how many cups we sell. And those total $280. On the other hand, our variable costs are how much we would sell, how much we would have to pay for materials for each cup that we sell, and it totals $1.20. Okay, so that means that whatever we charge, it's got to be more than $1.20 per cup. Otherwise, we're going to be losing money on every cup, because the materials for each cup of lemonade cost us $1.20. So that's how we would think about the meaning of that particular value right there. Okay. So now we're going to have to adjust our graphs, and I'll show you what we're going to do and explain why it is that we're doing that. Okay, so let's look at what we have here. So we still have our original P of x equals x. But now we have a P1 of x equals x minus 1.2. And what this represents here is that If X is the amount that we're charging per cup, we no longer get to keep all of that because we have to spend $1.20 for each cup that we make. So if I, let's say, make $4, if I charge $4 per cup, I'm actually making a profit of not $4, but 4 minus $1.20, or in this case, $2.80. And so I now have to multiply this new value times my quantity to get my revenues, but I also have to subtract the $280 in fixed costs. Those are the costs that I have to pay regardless of whether I sell a single cup, 1,000 cups. And those are, again, what are called our fixed costs. So now we have a new quadratic here, and you can see our original is much higher because we haven't subtracted out any costs yet. And so if we look at our new quadratic here, we can see that we get our maximum profit of $442, a lot different than $12.50, and that's if we charge $3.10 per cup. And so that's the price that we're going to have to set to maximize our profits as opposed to maximizing our revenues. And our profits then will come in at $442 per week once we've netted out our costs. Now you can also see that we have our two break-even prices. We have to set our price at least $1.61 in order to make money at all. Anything short of that, we're going to lose money because, as you can see, when the price is below $1.61, we are in the negative profit here. When the price is above $4 and let's say 59 cents, we're also in negative profit. So our price has to be somewhere between these two X values in order for us to make any profit. And again, our maximum profit is going to occur here at this price of $3.10 with a profit of $442.